Okay, back on the Hitachi 20VR2B. That is the 20-inch TV VCR combo that I previously diagnosed as having a shorted driver transistor in the power supply right here. Well, I did go ahead and order and receive 5, and you can't really see them on here, but they are the 2SC4130 transistors. And I did find what might be a close schematic. I'm not quite sure. But it does show that it does use the 2SC4130 transistor. So this is out of an actual VCR unit instead of a TV VCR combo. I couldn't find a schematic on this particular Hitachi that is actually made by Panasonic or Matsushita. So I'm going to go ahead and use this as my baseline to do my troubleshooting. So I know I tested some capacitors in the previous video, and I do need to do a couple of different tests at this point. Let me get a pointing device here. So if I go ahead and test this capacitor right here, this 330, and this capacitor, another 330. So let's just say this C2012 is actually defective, but because it has this 22, I believe it's probably microhenry coil configured as a pi network, this capacitor could actually be transferring energy through that inductor and test this capacitor as good. Similarly down here, C1016 could actually be defective, but C1017 could be good. So if I test C1016, it might actually test good because of this 9 microhenry coil that is in series with the two capacitors to configure a pi filter network. So let's go ahead and unsolder the positive leads of most, if not all, of these capacitors. Replace this driver transistor right here. And there's a couple of the capacitors I really want to check. I want to pay close attention to C1005 right here. That is the snubber capacitor. And if that capacitor goes bad, it will take out this output transistor. I've seen it many, many times. So I want to take a look at this 1 microfarad, especially down here, and basically any capacitor on the output side, as well as, I don't think this has a Zener diode. A lot of these had basically a Zener diode to ground. Oh, there it is right there. There is a MA2180 or an RD18FB 18 volt Zener diode that is on the 14 volt line. So if this thing begins to run away, whoops, sorry about that. If this power supply begins to run away, that diode is going to short to ground and basically clamp the output voltage on the secondary side of this transformer. So I want to go ahead and check everything to make sure it's copacetic, make sure everything is good before I slam a new 2SC4130 switching transistor into this unit. So I'm going to get the solder station warmed up and the solder sucker, and we'll desolder a bunch of these capacitors and test them basically out of circuit. And so I just flipped this board over and, well, shock face, I remembered I need to really check C14 and then D7 and R11, because that is all compromised by this one leaking capacitor that could cause major problems. Let's look at the schematic. So right there is C14. It is probably a 10 at 50 on this model, otherwise a 4.7 at 50. There's D1007, which is a reverse polarity rectifier to create a negative voltage, and then R1011, that's a simple 10 ohm resistor. Now look at that. It goes to the unswitched 30 volt supply, but if I follow this down right here, where does it actually go? Look at that. It's part of the feedback circuit that controls the optical isolator right here that controls the voltage output. So if this voltage right here ever gets compromised for any reason, that could actually skew the output voltage here into the optical isolator, and that is what actually controls the pulse width modulation or frequency of this unit. I'm not sure whether it uses PWM or frequency. Nope, no cats on the bench. So I definitely want to go ahead and clean all of that corrosion off of the board on R1011, D1007, and C1014 before I do absolutely anything else. Okay, so I did do some cleaning on the board, and I think I'm going to go ahead and run a jumper wire from this point right there. You can follow that trace around. It actually goes to this portion of the capacitor and this side of the diode. You can see that is very clear right there. And I did, let's see if it'll stay in focus. And nope. Let's go to manual focus. I'm sorry. Zoom out just slightly. So a lot of times it's helpful if you put a flashlight underneath the board. You can kind of see where the trace should run if there is a break in it. Now I did do an ohm test on this trace. It is good. I'm still going to run a little piece of enamel jumper wire just to make sure it is good, because I don't want this thing coming back. So a lot of times you can run a flashlight underneath here and see where the traces actually go, because in this situation right there, oops, too far. You really can't see where it goes, but I know for certain, yeah, you can kind of see it with the flashlight. Let's get the high brightness on there. Oh, come on, focus, you fuck. Today? No? Nope, doesn't like the high brightness. Sorry. So, like I said, we're going to run a jumper wire from this point over to the negative lead, I believe, of the capacitor and the anode of this diode right there. So I do have the original capacitor out of the board, and you can see it is very wet. So I believe that is probably the entire problem. Look at that. It's actually missing a lot of the writing on the case because of the leaking electrolyte. And you can tell it is a 10 at 50. So I will go ahead and replace that. Let's go ahead and check the rest of the capacitors. I do have all of the positive leads unsoldered, as you can see, right there, right there, right there, and right there. I'm not going to go ahead and unsolder these on this side because none of these are in a pi output configuration. But it's been a couple of weeks since I looked at this thing, and I do want to go ahead and test them again and just make sure that they are okay. Okay, ESR meter set up. Verify lead integrity is 0. Perfectly fine. So main filter cap, and that one is going to be a 120 at 200. And I get 0.4 ohms. I'm okay with half an ohm. This is the dreaded snubber cap. And I see 4.8 ohms. Might be just a hair high. I'm going to have to look and see if I have a replacement for that. I'm not sure if I have a 4.7 at that voltage. I do happen to have a couple of 10s at 250 that I can put in series. And so this one reads 1.7. And this one reads 1.5. So that would be what, 3.2 ohms? So might be a little bit better than what's in there right now. But let's go ahead and check the rest of these capacitors. So I'm going to check the pad first, and I get nothing. That's great. And this one is 44 ohms. That is the 1 microfarad cap. Just a little bit high in my book, unfortunately. Check the pad, nothing, and the capacitor 1.4 ohms. And what is the value on that guy? That's a 330. 1.4 is a little bit high in my book. And it goes through the inductor. Nothing on the pad. 3.3 ohms. I'm probably going to want to go ahead and replace both of those capacitors. Hopefully I have them in stock. So I'm just going to make a mark there and a mark there because I washed the board with acetone. And so this capacitor right here, we'll check the pad, nothing. And I get 2.8 ohms on that guy. And I really can't read it, but I think it's a 47. It's got a bunch of crud on it, so that one's a 47. I'm okay with that. And we'll check the pad on this one. Nothing. I read 0.1 ohms. That one is perfectly fine. And then check the pad there, nothing. And that capacitor is 0.16. That is perfectly fine. I am definitely good with that. So let's go ahead and change the defective caps and run a jumper wire, put a new transistor in this, and see if it fires up. Well, I ended up changing 6 of the output filter capacitors out of, I think, 7, because most of them were leaking. A couple of them did test very bad, especially this little 1 microfarad cap that tested 44 ohms. The replacement, I think, was like 3 ohms. So that thing was toast. So let's go ahead and take a look at the finished capacitor replacement. Now, unfortunately, I didn't have any 330s at 18 volts. So I had to use some 470s at 25. They're going to be just fine. Normally you can go up in value but not down. So the main filter tested good. The snubber cap tested good. And I did go ahead and add a enameled wire to the bottom of the board to repair the corroded trace, which wasn't actually defective, but it might over time. I did find that one of the 330s was leaking right there. You can see the dark spot on the board. So I went ahead and ran the capacitor lead over to here to make a good solid connection. Yeah, so anyhow, ready to go. New output transistor installed, new fuse installed. Let's get this thing reinstalled in the unit and hopefully does not blow up. Yeah. So I thought I'd take a look at the VCR mechanism before I put this thing all back together. I went ahead and I pulled the lid off of the unit, which is just basically this metal shield. Just want to take a look at it, make sure it's clean, everything's good to go. And holy crap. Yeah. That's all I can say. It's definitely a 2-head VCR. The cylinder turns extremely freely, which is excellent. But let me get that out of autofocus. Get a crisp, clear focus on this thing. Look at, oh my gosh. So I have no way of unloading the tape out of this thing because I'd really love to just blow the dirt out of this before I go any farther. So basically the only response I have is, yeah, this thing has been used. Holy moly. Did it just play this tape nonstop for like 17 years? Is there actually any protrusion on the heads? Yeah, there's actually a little bit. There's probably 4 or 5 thousandths of protrusion, so that's not bad. Yeah, I'm just gonna have to risk it. I want to go and blow this thing out, take it out to the garage and use the shop vac. Look at that. I may have to pull it apart and clean the mode select switch. That was not part of the original estimate, but I just wanted to get the dust out of it before I do anything else. Well, it looks a little bit better, I guess. Not quite so much dirt and hair. We did end up with a bit of slack in the tape, but hopefully it'll take it right up if everything's good, and if not, this mechanism's got to come out. All right, let's throw this thing back together and see what's going to happen. Alright, well, everything is reassembled. The VCR is put back together. The TV chassis installed. And then there is the little power supply that hopefully has been repaired. New fuse, new output transistor, new capacitors. 1, 2, 3, 1, 2, 3. Please do not blow up. And I heard a click, which is a good sign, but I don't have any power. But still, heard a click. No pops. Let's turn this thing around. This thing is freaking huge, almost doesn't fit on the bench. Okay, so here is power. And I get nothing. What the heck? All right, one moment, please. Well, I suppose it's my bad on this one. So hopefully you can see it here. Here is the replacement transistor, 3.5 ohms base to collector, 0.9 base to emitter. That thing is toast. Here is basically the driver transistor. That's base, collector, emitter, 3.3 megohms. Let's go to diode. Nothing. 1.6 volts. Reverse the leads. So base, collector, nothing. Base to emitter, nothing. That thing is toast. Doggone it. And it did blow the new fuse. Shoot. So let me see if I can find a suitable replacement. I know I don't have any of these things. 2SD 1458. I probably have another NPN transistor that will work in its place. Hopefully you can see it. Here's where it lives in the circuit. There's hardly any voltage on it. I just got to find one that has a current rating that is good enough. And I did go ahead and check these diodes. They do test perfectly fine. And let's see, A, B, C, D, E. I think this is an F, G, H, or I version. I did go ahead and check those diodes, and they tested perfectly fine. I did check this resistor. It is measuring like 0.19 ohms, which is going to be fine. That's the emitter resistor. Everything else tests fine. Well, let's go ahead and find a resistor and throw it in here, or a transistor, I should say. Throw it in here and see what happens. Luckily, I ordered, I think, 5 of the output transistors. So I thought, well, I got you here, I'll just do a diode test. Just verify that these things do have a good junction. 575 in one direction, open in the other direction. 595 in one direction, open, well, 1.6. There might be a resistor across that one, so that is D14. What is across that? The transistor is out. Huh. Opto-isolator maybe? Hard to say. Well, I'll go ahead and I'll do a diode check on the opto-isolator and see what it looks like. Maybe I'll go ahead and unsolder one lead of D14, see what it looks like. Okay, I do have one lead unsoldered from D14. So we've got 583 in that direction and open in that direction, so that is perfectly fine. Another little diode hiding down in here. It is on the hot side. 577, excellent. And open in that direction. So pretty happy with that. Let me go ahead and test the optical isolator just to make sure that there's no leakiness. Even if there was, it would actually hold the power supply back. 1.8 in that direction and open in that direction, perfectly fine. Okay, new transistor going in, new driver transistor going in, and we'll give this thing another try. All right, there is the original 2SD 1458. drop it in the tester, hit the test button, and it's basically two diodes, 3.98 volts and 718 millivolts. And as luck would have it, I did find an original 2SD1458 to replace it. Look at that. 1270 beta. That's the gain, the HFE of the transistor, in a forward voltage of 0.545 volts or 545 millivolts. Well, it's better to be lucky than good. So there is an original 2SD1458 that I harvested from a VCR, and we'll go ahead and throw it in here. Really hard to see, but that's one of the brand new output transistors, 2SC4130. I'm just going to test it to make sure that it's good. And it does test good. Okay, let's put this thing back together and give it another try. Alright, well, it's back together again. Let's go ahead and power this thing on. New fuse, new driver, new output transistor. And I hear a loading motor running. That's not good. And it does power up. Look at that. We have current draw. Do we get a picture? And we actually do get a picture. So the VCR power supply is repaired. Unfortunately, the VCR is not. It turns on, it turns off. Oh no, we gotta tear the VCR apart now. Really, right now? Well, let's try to get this thing apart. Just gonna do it, get it over with. Not sure how I'm gonna get the tape out of here without absolutely destroying it, but yeah, it's gonna be what it is. Kinda gotta get the tape off of the pinch roller, but it's fully loaded right now, so I can't do anything. Although, you know what? Yeah, the mechanism is loose. So underneath here, I can actually gain access to the pulley right there. So can I just... Wow. Oh. Am I going the right way? I have no idea. Obviously not. Okay, well, I figured I would just go ahead and give this thing some power with a suicide cord right here, and we'll see what's going to happen. 1, 2, 3, please don't blow up, as Chris Stevens says. Oh, I do not want you to reload. No, no reloading. Stop it. Okay, so I need to find the eject button. There it is, stop eject. There it goes. All right, got the tape out. We can tear this thing apart and get to that belt on the bottom now. I think it was just stuck. I'm hoping I have a replacement belt for it. All right, let's pull this thing apart and get to that belt. Okay, so I did manage to get the 2 screws out that the arrows are pointing to right there. So the mechanism is loose. I removed the screws from the bottom of the board, or at least I think I did. So next, it's got these little hinge connectors on the back right here, and we just need to pop those out. Just a little bit of downward force, and why is it not releasing? Did I miss the screw on the bottom of the board? And yes, I did. That would have been tragic. I don't want to have to run 57 jumper wires on this board. Come on, out. Yes. Okay. Now this thing should pop out. Come on. Release. Release. There we go. And it is out. Hey, look at that. There's the mood select switch. Probably want to clean it while we're in here. So there is the loading gear and the loading motor. So we know it's probably going to mostly work. Did make a weird sound, but might just be a bad belt. Who knows? Oh, and yeah. Oh, that thing is toast. It's not too bad. Oh, shoot. I'm probably going to have to order belts for this thing. Doggone it. So if you're going to tear one of these things apart, make sure that you get the alignment marks aligned right there. So as you can see, there's a dot on the white gear and a single dot on the black gear. Those need to be lined up. There's probably another alignment mark somewhere. I did try to lift the mechanism out, so it might be one tooth off right now. Let's go ahead and flip it over. And there should be some more alignment marks. So there's a notch right there. It lines up with that dot. And I think I probably got this out of time because I did take these two French screws out before I put it back together and tried to unload it manually. One of the things to look out for is this mechanism right here. Always want to add a drop of oil to that, because if it binds up this little, I think it's phenolic. No, it's not phenolic, but it'll actually break that gear off. Let's remove that. So it'll break this little tang in the back off right there if this thing gets gummed up, which it feels gummy because it should snap back. And I feel a bit of resistance snapping that thing back. Yeah. The gift that keeps on giving once again. Okay, I'm going to go ahead and pull the mechanism off of this unit, or the carriage I should say, because I do believe I have it off by one tooth. And we'll see if there are alignment marks on it. As I recall, there are. Stop it. Oh, sorry, you couldn't see that. Okay, so now let's zoom out where you can see what's going on. This thing should just lift up and out. And I thought there was some kind of an alignment mark. No, maybe I was wrong. I thought I was wrong once, but I was mistaken. Okay, there are the alignment marks. Make sure those are perfectly straight across from each other. As you can see, I can move them a little bit. They want to be right in the center right there. Okay. Now we'll go ahead and pull these two screws out, and that's going to lift this basic mechanism out of here. Once again, paying attention that you have your alignment marks in time right there. Can almost get the belt off. Not quite. Gotta pull this worm gear out of here. And as I recall, it just snaps into place. A couple of tangs right there. And they do retain the wires. Wow, why do you gotta be like that? Okay. I'm just going to pop the belt completely off. And then this should just pull up. It's got a center hole for the gear. And then I believe the shaft actually can pull out of the gear at this point. Or not. There we go. Yeah, that belt has been sitting there for a day and a half. Well, I'm going to have to see if I can get a belt kit for this, because I don't think that I have a belt for this. But I will look. I will look. One moment, please. Well, once again, it's better to be lucky than good. As luck would have it, I had one loading belt left in stock. There it is. So make sure, once again, when you reassemble this unit, that you line up that dot with that dot on the mode select switch with a little indentation on the mode gear. So I am going to go ahead and pull this off and clean the mode select switch just to make sure everything is going to be good. I did have an extra drive belt right here installed. Clean the pulleys with acetone, clean the pulleys, clean the belt. Everything's good at this point. So let's get the mode select switch cleaned up and get this piece of, you know what, back together and ready to get picked up by my customer. Oh, doggone it. Why's everything got to be so freaking hard? There's a single screw on the circuit board. I can't lift the mode select switch out. Wow. Well, once again, I'm stuck in the Jelly of the Month Club. The gift that keeps on giving the whole year. Okay, now we can actually get to the mode select switch. So, as with every other mode select switch, it's got tabs on the back. And I don't want to break anything, so I'm going to encourage these guys to please release nicely. Almost. Yes. And it doesn't look too terribly bad. I think we can just go ahead and give it a wipe down in just a brief stainless toothbrush, a bit of dielectric grease, and I think this thing is going to be good once again. Hopefully it's still in view for you guys. I like that. Much more shiny. We'll give it a quick wipe down. No acetone needed on this one. And that looks way, way better than when we started. I just want to do a quick wipe on the contacts. The bigger the glob, the better the job. Dielectric grease going on in. This prevents oxidation on the silver-plated contacts. If there's a hair, I don't really mind. It'll move its way out of the way as time progresses. Snap the two halves back together. I said snap the two halves back together. Run it around a bunch of times, which is harder to do on this one. It doesn't have a tab like the Magnavox Funai symphonic units have. There's the dot. Oh, this one's a nightmare to line. Oh, that's because I don't have it lined up on this side. Doggone it. There we go. Get it in the slot. Okay, so it's in the slot. I'm going to take a flashlight. And yes, the dot on the gear is lined up with the dot on the mode select switch itself. Sometimes you want a magnetic screwdriver, and other times you do not. Okay, lined up, lined up. Goes underneath the belt. There we go. Make sure everything lines up perfectly. All right, let's sew this thing back together. And as you can see, I'm off by a tooth on the top. Shoot. Well, it doesn't like that at all, does it? Let's try a different flashlight. So if you look down in that little notch, you can see a hole right there. And so this hole is supposed to line up with that. So I already got the top off right here. It just lifts out of place with a clip. So I'm going to move that up, and hopefully I can lift this up. And nope. Why has everything got to be so freaking hard? It's got a clip right there. I think I can back those out just a little bit. And I hope I can push that down then rotate that one tooth and push it back up into place like that. And now that hole is aligned with that hole. I'll flip it back over. Still aligned. Should be still aligned. Tighten those back up. Make sure that cable is tucked away. I think they must have some very tight tolerances assembling this thing. So you probably couldn't see much of that. Let's turn off manual focus. So we are aligned here. You can see the indentation is lined up. Those two are lined up perfectly fine. And then back on the top, those are lined up. Need to service that. I think on some of these you can just press, yeah, you can just press it down. I'm just going to add a drop of oil to the shaft. Work it in a little bit. Oh, feels much better. Okay, I'm happy with that. Pinch roller assembly going back on the Christmas tree is what they call this spiral gear right here, the Christmas tree. I'm not sure who named it that, but it works. All right. Let's put this thing together, finally. Oh yeah, much better. Okay, suicide cord still connected. Let's get the mechanism into view here, and we'll power this thing on, see what's going to happen. Don't blow up, please don't blow up. Hit the power button. The light lit up, that's perfect. And we'll pop a tape into it, see if it wants to try to accept it. And look at that, it's actually playing a tape. Let's see if it plays more than about 7 or 8 seconds. Make sure the reel rotation is actually working. Oh man, what a freaking long road to get to where we are right now. Man, this is 50 miles of dirty, bumpy, nasty rut road. So I've already went ahead and did a cleaning off camera, the entire tape path. Everything is great. So next, just got to put this thing back together. Okay, I'm happy with that. Let's stop it and eject it. Let's make sure it plays an SP tape. And it gives the tape back perfectly. So I believe the first few seconds of this tape are in SLP, and then it switches over to SP. So you should see a speed up of the reels here momentarily. So that is definitely SLP. And there's SP. Great, I love it. Hopefully it plays video. That's all we're missing is actual video. So stop, eject. I can probably tie into one of these cables and it'll actually provide video, but I'm just going to go ahead and put it back together in the unit and cross whatever you've got that there's no other issues. Like I said, 50 miles of dirty, bumpy, rutty road. And yes, I did replace the missing screws there on each side. The transport screw and the rear brace and the rear brace screw. So it is ready for reassembly. All I have to do is put the shield back on it, slide it into the chassis, and we should be on a home run. Okay, and since I'm here I'm going to go ahead and solder the driver transformer. This is the horizontal driver transformer, and they have a tendency to break free from the circuit board over time because they operate at, I believe it's 15,734 hertz or 15 kilohertz, and they do break free over time. Just as a preventative measure, I should go ahead and solder the vertical chip. Ow! Ah! That's my toe. IC 451 right there. Let's turn off autofocus and look at the pins on it. And I think I'll let that slide. It looks pretty good. It's probably an LA7838 IC. My toe might be bleeding. Well, I was incorrect. It's an LA7835, probably a little brother of the LA7838 vertical output IC. But everything looks good. Let's throw this thing back together and give it a final test. Well, I might have been incorrect on the horizontal driver transformer because it's actually this one. These had a tendency to break loose over time, and when they broke loose, the horizontal output transistor would basically freewheel and short, and that would be the end of the line. So T501 soldered. So as you can see, it goes through this trace through an inductor, and then it goes to the base of the horizontal output transistor. That, if I can get it into view, lives on that heatsink. On focus, really right now? There we go. Lives on that heatsink, a 2SD2369. Well, had a couple of bad parts, no doubt about it. So let's go ahead and power this thing on. AC power has been applied. We'll hit the power button. It did come on, it did degauss based on the current that I saw. Hopefully we'll get a screen on here. And I do have the exposure set to 1/60th of a second here. So hopefully it's not too nasty. That looks good. And let's go ahead and pop a tape into it. This is an SP tape. Come on, focus. Really right now? There we go. And look at that. It is actually playing an SP tape. That is awesome. I hear sound. Let's put the sound down. It looks good. No problems whatsoever here. Let's go ahead and pop that out. Stop. Eject. Come on, baby. Come on. Spit it back. Yes, the door opened. Everything. Perfect. Let's grab an SLP tape. I could grab the customer's tape, actually. It's right at the beginning, so hopefully it's not contaminated. Oh, jeez. I'm taking a big gamble on this one. And I got nothing. Let's fast forward a bit. Oh, I got nothing. The heads are clogged. Oh, really? I gotta tear it apart and do a cleaning? Oh, let's try the SP tape again. Oh, this is definitely the gift that keeps on giving. Yeah, and it clogged the heads. Wonderful. Alright, well, one moment while I tear it apart and clean the heads again. Okay, customer's tape going in once again. After cleaning, I did advance the tape slightly. And it shows that it is playing. Oh, there it goes. We have motion. Yay! This thing is actually working. This is a SLP tape, I do believe. Let's go ahead and hit fast forward. Pretty sure that's SLP. Might be it's LP, I'm not sure. And yeah, let's go and eject this back out of here. And I'll put in my SLP tape, because I think we should have much narrower noise bands. There it is, play. Stay focused, please, stay focused. And that is playing perfectly. Okay, that's an SLP tape if you notice the size of the noise bands. So we'll stop it, eject it. I'm going to put an SP tape into it, which is an Eastman tape. And it's playing perfectly. Fast forward. Oh, maybe it was an SP tape after all. Wow, okay. Must be very short stories then. Anyhow, there it is. The, I forgot what the model is right now. Hitachi 20 VR2B. I think it is. Might be wrong. Who knows? But anyhow, it's working. Oh my gosh. So it's currently, if you can see the clock over here, it's almost 3 o'clock in the morning. And I've been working on this thing since about 11 o'clock last night. Finally got it going. Oh my God, what a long road to get this thing actually repaired. I certainly hope you enjoyed the repair on the Hitachi TV VCR Combo, made by Panasonic, incidentally. I know I mentioned that in the past, but it is a Panasonic unit. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, if you could please hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, the platform formerly known as Twitter or X at NorCal715. You can email me, norcal715videos@gmail.com. Once again, as of right now, please, if you want to contact me, leave me a comment on one of my videos. I'll probably respond to that much faster than I would if you email me. Once again, so hectic after the accident. I'm still trying to get caught up. It's been such a long road. I really, really appreciate you making it to the end of this video. Once again, thank you so much. Everyone have a great day. Thanks for watching. Bye-bye. And yes, I did test the customer's remote, and it is working absolutely perfectly. Power off. Everyone have a great day. Thanks for watching. Bye-bye. Well, I did not estimate that, so I'm going to leave it at that. The TV portion is repaired at least. I'm going to have to give the customer a revised estimate. I only estimated $75 to repair the VCR portion of the TV portion, which includes the VCR power supply. But that is working. It's working flawless. So the reason you don't see the full screen is because of the shutter on the phone and the vertical blanking interval. But I assure you, it is a full picture. Doggone it. This thing just is the gift that keeps on giving, like the Jelly of the Month Club. That's right, Clark. It's the gift that keeps on giving. Well, we're going to end this as part 2. So we actually accomplished something. Had to replace the driver transistor, and that's a spare that I found that's not quite perfect, but I think it would have worked. Anyhow, in addition to all of the capacitors and the output transistor, yeah, here we go. Like I said, the gift that keeps on giving. Everybody, thank you for making it to the end of this video. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. That is not the best way to contact me at this point. Leave me a comment on one of the videos. I'll try to respond as quickly as I possibly can. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. It's probably going to be a very long one. Anyhow, I really, really appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye. Because I do see that there are a couple of capacitors that are configured in a pi filter network, which means, let's just say this capacitor is toast right here, and I ESR this capacitor right here. Well, because of this inductor, this capacitor might actually test good. So I need to go ahead and unsolder at least a positive lead from one of these two capacitors. Oh, let's take that again, because I forked up. Whoops, start over.